Hello students, today we will start with Chemistry chapter 5. The name of the chapter is Language of Chemistry. In this slide you can see atoms, molecules, ions. So what are those? Atoms are the smallest particle of an element which cannot exist independently. Then molecules are the smallest particle of a substance which can exist independently and also retain the characteristic features of that substance. And ions are atoms or a group of atoms which has a charge in it due to loss or gain of electrons. Then elements and compounds. Elements are pure substances which cannot be broken down into two or more simpler substances. And compounds are also pure substances formed by combination of two or more elements, and those compounds can be broken down into its constituent elements. Now, moving to the next slide, that is symbol of an element. So what is symbol? Symbol is the short form or abbreviated name of the element. It represents a specific element or one atom of an element. So this symbol was first proposed by John Dalton, but that symbol was not taken as a scientific one. Then Berzelius suggested the steps how to represent elements with their symbol. So what are those steps? Those steps are: first, we have to take the first letter of the name of an element. Then the first two letters of the name of an element. And lastly, the Latin name of the element. Now, this slide is all about valency. So what is valency? Valency is the number of hydrogen atoms which can combine with or displace one atom of the element or radical forming a compound. So when I'll give you the example, it will be very clear to you. For example, HCl. In HCl, one atom of hydrogen combines with one atom of chlorine. So as with the chlorine atom, one atom of hydrogen is getting combined. That is why the valency of chlorine is 1. And another example I can give, for example, water, H2O. Here, two atoms of hydrogen combine with one atom of oxygen. As with one atom of oxygen, two atoms of hydrogen are getting combined. That is why the valency of oxygen will be 2. The next one, like ammonia, NH3. Here, 3 atoms of hydrogen combine with one atom of nitrogen, and therefore the valency of nitrogen is 3. Now we will learn about some other examples to calculate valency. When we have to calculate the valency of some elements which do not combine with hydrogen, then we should know the valency of the other element. Like for example, when we have to calculate the valency of zinc from the compound zinc oxide, then we should know the valency of oxygen. So now if we think of the previous slide, we already have calculated the valency of oxygen from H2O. So H2O, two atoms of hydrogen getting combined with one atom of oxygen. So therefore the valency of oxygen is 2. So now we know the valency of oxygen is 2. So we should calculate, and we know also from zinc oxide or ZnO that the valency of zinc will also be 2. We should know this statement: the valency of all metals is considered as positive and non-metals as negative. This statement is very, very important. Now in this slide we will learn about variable valency. So what is variable valency? Certain elements exhibit more than one valencies. Those we call as variable valencies. Now in very simple language, valency is nothing but the number of electrons lost or gained from the outer shell of an atom of an element during a chemical reaction. So the number of electrons lost or gained from the outer shell. Okay, from the outer shell. This statement is very important. Now for variable valency, we know that copper has variable valency. Why? Because copper has one electron in the outermost shell normally. Okay, it has normally one electron in the outermost shell. But during any chemical reaction, due to its instability or unstable nature, one or more electrons sometimes jump to the outermost shell from the penultimate shell, means the previous shell, means the outermost shell and the second last shell. Okay, so sometimes what happen, one or more electrons, they jump from the second last shell to the last shell. Okay, that is why copper shows variable valency, and this happens due to its unstable nature. Okay, during any chemical reaction, due to its unstable nature, this jumping of electrons occur from the second last shell to the last shell, showing variable valency. In this slide, you will see the valencies, the positive valencies and the negative valencies, and the metals or radicals with positive valencies and negative valencies, their symbols, the ions, everything you can get in this slide. And you have to learn it. You have to by heart this slide. And here are some examples of elements exhibiting variable valencies like copper, silver, iron, tin, phosphorus, sulfur. All these are elements having variable valencies. In this slide, we will learn about iron. So what is iron? An ion is any atom or a group of atoms carrying a positive or negative charge due to loss or gain of electrons. So ion, it can be an atom or a group of atoms which is carrying a charge due to the loss or gain of electrons during any chemical reactions. For iron, you have to learn two terms. The first one is cation and the second one is anion. So what is cation? The positively charged ions are called cations and the negatively charged ions are called anions. Example of cation, Na plus, and anion, Cl minus. Now, radical. What do you mean by radical? Radical is group of atoms of elements that behave like a single unit and show valency. Like for radical, it can be a group of atoms. For example, ammonium, NH4. So it is a group of atoms. It has atom of nitrogen, atom of hydrogen. So it is a group of atoms of elements and it behaves as a single unit. Like NH4 will behave as a single unit. It will not have two different characters of nitrogen and hydrogen, but will behave as a single unit and it has valency. Those are called radical. For example, ammonium bicarbonate. So for this radical also you have to learn two terms. The first one is positive radical and the next one is negative radical. Positive radical like ammonium NH4 plus and negative radical like bicarbonate HCO3 minus. Now we will learn about the periodic table. In our Earth's surface, there are almost 118 elements. But if we have to remember the information about all the elements, it is impossible for anybody to remember like that. To make it easier, Mendeleev has classified elements systematically in a tabular form which we call as periodic table or the modern periodic table. In this slide, you can see the symbols and valencies of the first 20 elements in the modern periodic table and the electronic configuration also. So you have to learn the symbol, the atomic number, the electronic configuration, valency, and what type of elements are they, like metals, non-metals, metalloids, or noble gas. Thank you, class. So you have to go through the PPT and simultaneously just read the chapter carefully. The chapter will be very easy to you now. So do it and study well. Thank you.